Irodov problem number 1.129. A system consists of two springs connected in series and having the stiffness coefficients K1 and K2. Find the minimum work to be performed in order to stretch this system by delta L. Okay, so for this question, it says there is a system of two springs that are connected in parallel. Okay, and one of them has stiffness coefficient K1, the other one has K2. Now for the system to elongate by some distance delta L, what is the minimum work that needs to be performed on this system? Let's assume that this particular spring is elongated by L1 and this particular spring is elongated by L2, such that delta L is equal to L1 plus L2. Okay. Now work performed by these springs when elongated by L1 and L2 respectively, we can write that as minus half K1 L1 square minus half K2 L2 square. Okay. Now if I replace L2 by delta L minus L1, we can write minus half, we can take common, K1 L1 square plus K2 delta L minus L1 square. Let's just expand that, minus half K1 L1 square plus K2 delta L square plus K2 L1 square minus 2 K2 delta L times L1. Okay, we can further write this as minus half K1 plus K2 L1 square minus 2 K2 delta L times L1 plus K2 delta L square. Okay. Now let's just call this W. Now for this work done by the springs or on the springs will be negative of this. To be minimum, we need dW dL1 to be 0. Okay, because we are doing it as a variable on L1. Okay, delta L is a constant. So let's just differentiate this. So dW dL1 is how much? Minus half remains outside. This becomes 2 K1 plus K2 L1 minus 2 K2 delta L, and this is 0. Okay. So using dW dL1 is 0, we get the condition as K1 plus K2 L1 should be equal to K2 delta L. Or we can simplify this as L1 is equals to K2 delta L divided by K1 plus K2. By symmetry, we can also write L2 as K1 delta L divided by K1 plus K2. Okay, so we got the values of L1 and L2 for minimum work done on the springs. Now let's just substitute that. So work minimum And in the question it is asked what's the minimum work to be done on the springs. If the work done by the springs is minus, then work done on the spring should be negative of that. So we can just eliminate the minus sign and we can write half K1 L1 square plus K2 L2 square. Okay. Now let's substitute the values of L1 and L2 for minimum work. So half K1 L1 square. So we have K1 plus K2 whole square in the denominator, and this will be K2 square delta L square plus K2 K1 square delta L square divided by K1 plus K2 whole square. Okay, so we can take K1 K2 by 2 K1 plus K2 whole square common, and also delta L square common. So what is remaining is K2 from here and K1 from here. Okay, so one of these gets cancelled out, so this becomes K1 K2 by 2 K1 plus K2 delta L square. So work minimum is this. Okay.